So we've already said on a position versus time graph that if we have a horizontal line, that is speed equal to 0. That's something just sitting still. If we have a line with a positive slope, that is something moving at a positive velocity. It's also true that we could have a line with a negative slope. And so this would be a velocity less than 0, which would mean that the object was moving backwards. Well, now with acceleration, we can throw in forward and backwards also. So for example, when we have a curve like this, a nice concave up curve, well, this is ordinary acceleration as we usually think about it. In other words, this is the car in drive, and the person is stepping on the gas, and the car is accelerating forward. But we might look at a curve that goes like this. And so notice what's happening is that with this one, this is concave down, and the slope is getting more and more negative. The absolute value of the slope is increasing, but it's pointing more and more in negative direction. This would be if the person put the car in reverse and then stepped on the gas. So this is accelerating backwards. We can also talk about a curve that looks like this. Well, this is interesting. This starts out with a very, very high velocity, and then that velocity gets lower and lower, and in fact eventually goes to 0. So this is something that we typically would call deceleration. Now, of course, in physics we know that deceleration is a kind of acceleration, but this is called deceleration. And so this would be the car is in drive, but the person is stepping on the brake. And so velocity is decreasing. And of course, whenever velocity changes, either increases or decreases, that shows up on an x versus t graph as a curve. Finally, we can have a curve that goes like this. So this was going very negative and then less and less negative and down to 0. So this also is a deceleration, but this was a deceleration of a car that was moving backwards. So this is deceleration backwards. In other words, the car is in reverse and the person is stepping on the brake. And notice that in the cases that are concave up, and that would be both accelerating forward or decelerating backwards, in both of those, concave up, the slope is increasing. In accelerating forward, what's going on is that we're starting with small positive values and moving to larger and larger positive values. We're decelerating backwards, we're starting with large negative values and then moving up to smaller and smaller negative values, eventually moving up to 0. So in both cases, we're moving up when we have a concave up graph. Similarly, on the concave down graph, well, on this graph, we're moving from 0 to bigger and bigger negative numbers. From this one, we're moving from a positive number down to smaller and smaller positive numbers. So in both cases, on a concave down graph, what's happening is that the numbers for slope are decreasing. Those are usually important ideas which will come into play when we talk about the first and second derivative.